So hi again everyone for the people I have not seen before. So we'll look at my title says Qt Quick 2 components accelerated with Open GL. We'll see why there is no difference compared to Qt 4, and that's why we did this presentation. So my name is Adrien Leravat. So I'm in France. I'm a French guy. I work at Adrien Leravat, and I'm an embedded software engineer. So the context of yes before also. Usually I have one colleague at least with me. Yes. Feel free to interrupt me if you have questions or if you don't understand what I'm saying, and also if you want to ask your question in Italian, that's fine. And Marco will probably translate me in English, so hopefully. Thank you. The context. When you build your Qt Quick application, I think probably you know that it's all about creating your own component. When you create your Qt Quick application, you will have to create your Qt Quick component because it's not like with the C++ widget where you take a button or something existing. In Qt Quick, most of the time you have to create your own object to be shown on the user interface, because you need some special things for refactoring or for viruses. That's very, very common. And indeed, this process is made very easy by Qt. So it's just like creating a file and putting your elements inside, and you have created your component. Much easier than, for example, creating a class in C++. Now, the basic way to create your Qt Quick component is some kind of, I would say, aggregation. So you create your QML file, and inside you will put different existing objects. So that's really, really easy to do. You just put a rectangle something, and you have created your components. And of course, the limitations that you are limited by all the existing components, the component that already exists, you can integrate only this one. And also you are on the Qt Quick side, so you have limited access to all the C++ data or things. One example, really quick, of a Qt Quick component. So you create, for example, myComponents.qml. You put your things inside, and you have created an element that you can use anywhere else just by doing that. So you write simply myComponent somewhere else in your code, and that will automatically load this component. So here, for example, we create a rectangle. Inside, we put a loose area, and when we click on that loose area, there will be a space. Okay, so that was the very basic one. Yeah, also, the aim of this presentation is to show how to create an accelerated Open GL component. So the limitation here is that you will not really be able to draw anything complex by aggregating it, or just rectangles, things like that, but you are quite limited. And even though Qt Quick 2 uses completely Open GL under the roof, it's likely that you can achieve better performances if you somehow do it yourself. Another way, more powerful, to draw something on in Qt Quick is to use Canva, which was also introduced with Qt Quick 2. Actually, it's very similar to using your HTML5 Canva, and it offers some great drawing possibilities in a really simple manner. So it's used directly for QML. You don't have to write C++ code for that. And the drawback is that it's also somehow limited because you don't call directly OpenGL, and you have also limited access to C++ data. So here is an example. You have your QML file, some file, and inside you create a Canva element. And inside that Canva element, you will use the unpaint handler to write your code that will draw something. For example, here we move to some position, we draw a path, so with Bezier curves, we fill the shape that we have created, etc. I skipped some parts here, and the result is, for example, something like that. So you can create, I would say, advanced drawing simply by using this HTML5-like mode to draw your elements. Yes, and to update your component, you have to call request paint. If something changed, requesting changing the appearance of your component by calling request line that will just redraw completely. Also, this is something that exists in Qt Quick, in Qt project website. That's one of the tutorials, I think, which is called Canvas. Now we have a less easy way, which is creating your own Qt Quick item class. So here now we are on the C++ side of Qt, and on the C++ we want to create some component to be used inside Qt Quick. So this is indeed less straightforward, but it really lets you customize completely the component and also the painting that you are able, that you can do. So we have complete direct access to all the C++ thing that you can have in your application, and you use C++ at its full power directly on the C++ side. You have different ways of doing that. Before, with Qt 4, there was, from what I know, only one actually. So with Qt 1, the engine was not based on Open GL. That was not the base of it. And you simply have to re-implement, to create a class and inherit Qt decorative item, then re-implement the paint method, and by doing so, you can draw your component directly using QPainter, like you did, for example, with widgets. That's the first method, but it only applies to Qt 4 and Qt Quick 1, because then with Qt 5, that changed indeed. Now, the items are based on Qt Quick item, and from Qt Quick item, you have no paint method. So the first time you see that, you say, okay, now how can I create my component? How can I draw it? Again, several ways. Probably always several ways, but you have one way to be like in the middle between Qt 5 and Qt 4, which is using the Qt Quick painted item. This one uses Qt 5 components and everything, but it provides a paint method just like you had before with Qt 4. So this is a way to port your code, soft way to be able to draw things without having to use Open GL Qt classes. So it's very convenient to use, but of course it will not fully leverage all the things that have been added to Qt because it's some just convenience class to make things easier for you. And now we'll see how to create really Qt Quick 2 items with Open GL. And unfortunately, that will not be really simple, but at least you will know, have a look of how to do it. So one main element introduced with Qt Quick 2 is the scene graph. Now this scene graph completely relies on OpenGL and OpenGL ES, and the advantage of that is that it can proceed to huge optimization in order to draw things really quickly on your targets. So for example, one case that we have is that in my project we often work on embedded devices, and on embedded devices you have sometimes the graphical acceleration, but still the power of it, the CPU is relatively limited, quite like on the smartphone, but the non-CPU that's not like having an i5 processor. And so if you try to draw complex things or a lot of things with the traditional manner, without this acceleration, you may end up with performance problem. And so the scene graph is the answer to that solution, and using OpenGL is also the solution to that problem. So a few optimizations that the scene graph does is, for example, sorting all your objects by material, not drawing all the components that are hidden, etc. OpenGL optimization just to reduce the processing time. And also it runs now, that was not the case before, but now it runs in a render thread, which is actually completely different than before. To just describe it a bit more, because that will be useful for the next presentation. So this scene graph uses what is called nodes, and a node is like an element which can have children, which can have also parents, or quite like Q objects, etc. And this node will contain all the graphic information, all the information of an element. For example, here you have like a big node which is the square, then a node here which is a child of this one, and again another node, etc., etc. So we have a hierarchy of all the nodes for your application. And how to freeze, so now leverage how to use that. You have the paint. So we'll inherit the Qt quick item. We'll have to set this flag to say, okay, I want to draw something on the screen, and I will print an error and assert in your when you try to execute the program. And re-implement the update paint node method. Now this method is quite strange, so we'll see that. From that method, we'll use the scene graph classes. So you have a whole large number of classes that you can use to help you create accelerated components. And then elsewhere, when we call update, or inside a component, you will re-trigger the update, the drawing of your component, most like you did for any component of Qt widget. So yeah, when we have that's of course one of our partners, so just one slide about that. When doing so, of course, you have to make sure that your device actually has graphical acceleration. And this is not the case of all your devices. This is definitely something you want to check with the constructor, or just the manual of the thing that you try to target. For example, you need 3D acceleration, Open GL 3D acceleration, and if you do not have that, Qt Quick 2 is likely to run really slower than on a regular device with acceleration. For example, with that's a bit of the the dark corner of Qt and compiling Qt. When you compile Qt for one component and you try to enable OpenGL, you have to set some of the flags. You have the QML which is this platform-specific configuration with all the tools needed to compile for example, the toolchain, etc. And during configuration, you have these lines to say my device is that, and the most important being enabling OpenGL ES. So OpenGL made for embedded or smartphone devices, and enabling EGL FS. There are other backends you have, but basically this is one graphical backend of Qt 5, which is completely based on OpenGL and will let you use the power of Qt. So as you see, you have the backend, you have how you use your application, and then how you create your widgets. And you have really to make sure that all these elements are made in the right way to leverage fully over OpenGL, else that will just not perform as good. So here is the famous update paint node, which is, okay, I'll try to explain you. So we enter in this method when we will update or draw our component, which we have, the thing we have here in old node is the state of the node we are drawing, so kind of like the component, right before entering this method. So this is a bit different from the update and QPainter when using the previous way of drawing component with Qt. You have no previous state, you just draw your element, you draw your line, you draw anything, and that's it. Here you have to manage the previous state of the node, again for optimization, because now Qt and Qt Quick works that way, and so you have to use that. So we try to retrieve, for example, a simple rect node that's a class made by guys from Gigi actually, to make your life easier. So that's like a pre-made node that will display a rectangle. Make sure that it exists, and if it doesn't exist, which means that the first time you paint your element, for example, create that element, set a color, and resize this element with the size of your Qt Quick component. So on the QML side, you have a component, for example, you set its size to 200 pixels per 200 pixels. By calling bounding rate, that will retrieve this size from the QML and change the size of your element. Now, there is a lot, probably not the only one, but there is some caveats to be avoided. When you are in this method, you have to be sure to draw exclusively on the render thread. Now you are on one thread, which is the rendering thread, but you have the main thread that holds your application and your data, etc. And if you try to interact in a bad way, you may have, for example, the main thread which draws something in this render thread, and the result will be just, well, your application crashing. As always, when doing things with threads are really a great thing to separate different processes, different operations you have to do, but you have to be very, very careful. The main thread is blocked during the rendering, which means that you can access data of your item without wondering if it's modified by the main thread at the same time. The newly created QObject base class, for example, are running on the rendering thread, so all the objects you create during the render of the object are created on the rendering thread and not on the main thread. So if you create objects at this time and try to access them from the main thread, that will probably cause problems because you have two threads that are sharing an object, and then usually bad things happen. But Qt has a really nicely designed Qthread modules, but that's a completely different story. I think there is a presentation to do also about that. And signals targeting main thread will be Qt here. So if you have connection, that will still work because Qt is made in a nice way, but you just have to be aware that it will not be processed directly, but a message will be posted and then received later by the main thread. Okay, enough of this. Now we'll see some node class. So the node class is really the base class of your scene graph, the thing you use to draw the frame. And you have some iterative class from it. For example, you have the transform node. So this node is used exclusively to transform the graphics, to apply rotation, etc. So if you want to support this kind of feature, you have to create a transform node. Same thing applies to, for example, the opacity node. So the names don't tell us everything. If you want to support opacity, for example, change the opacity of the whole component and all the children, you will use this one. The clipping node, then, if you need, for example, to cut the content of what you are drawing. And finally, the geometry node, which is the only one here which actually draws something. The other one are most like utilities nodes used for specific operation, but not to draw things. Because with Open GL, you can't just draw, for example, a rectangle like that. You have to handle, you have to create vertices, you have to connect your vertices, you have to set the color of everything, etc. That's really more complex than using, for example, the incubator. And inside this geometry node, you have several also classes. I didn't put everything here. You have the simple rect node that I quickly showed to you. So this is really just, it will create a rectangle and you will be able to change the color of this rectangle. So a really fast way to start creating something and looking that it works for sure. And another one, for example, which is the simple texture node. So let's say you have an image to display. Like an image is actually a texture. So you will create a simple texture node, set this image as texture, and then render that on screen. A small example with geometry, probably just to say that it's quite complex. So geometry in Open GL when rendered, it can be, there's different types of geometry. The base element of geometry is always the vertex. A vertex is a point in the space in 3D. And from that vertex, you will be able to draw points, lines, so vertices that are connected, or triangles, which are like 3 vertices connected together. And when, for example, drawing a rectangle, actually that's 2 triangles put together internally. So let's say you want to create a new shape And okay, that's not that simple. You create your geometry, so we are inside the update function for our component. You create your geometry. You set the default attributes of your point. You will say, okay, I want to draw lines. I want my line to be of this width, so in this case, 3 pixels. And you will here add vertices. So here what we do is really creating vertices. So here we create one vertices at 0, 0 position. Actually, that's easier because we use Qt10, so Qt internally can convert these 2D points into 3D points. We create a first point at 0, 0 and another at with an 8, so that's like you have a rectangle and you will have a line from the top left to the bottom right. Finally, so that was only the geometry. Finally, you create your geometry node, the element which is inside the scene graph. You set geometry into that node, and for example, that's optional, but you can set all geometry. And when you will delete your node, it will automatically delete geometry. So I guess quite complex, maybe too complex, but that would really depend on your needs and yeah, the needs of the thing you are creating. Then you have the materials shader, so material, flat color, etc. Internally, what a material is in Open GL is a shader. A shader is a small piece of program, almost like very close to C programming, that is run on your GPU and applies transformation to all vertices for the vertex shaders and all fragments, so all pixels for the fragment shaders. That's really a low-level program that runs on your graphical card, on the GPU, on the 3D part of your CPU. And again, they made a few classes to make your life easier, that you don't need to write shaders all the time, because that's some additional work too. So you have the flat color material, which is a shader that sets the same color for all the pixels. For example, we set the color to a red here. And you have, no, that's all for this one. Then you create a simple rect node. Oh, my bad. Okay, here that should be geometry node. So you create your geometry node. You set the geometry that you have created a bit above. Sorry. You set that flag and you set also the set material. Who wrote that? Probably not me. Okay, you get the idea. So you create a material, you associate it to your geometry, and then it will apply to a geometry that you have created. That's already the summer. Okay, then I have a few examples to show you, because that's always better with an example, of course. So basically, Qt5 provides now a way to create really high-performance graphics content and really accelerated content with Qt Quick 2, which was not the case before, because even if it was relying on OpenGL, there was all the QPainter, etc. stack that was preventing a lot of optimization from being done. And now we can really write something which is close to OpenGL, so really fast to be run on your hardware. The problem is that now it really needs some OpenGL knowledge and thinking when creating your components. And I think that you have seen that it's a lot, probably more difficult than drawing something and doing draw line and fill the thing, etc. That's really completely different. And so when you don't really need this big optimization, you have always some alternative, hopefully. So the Qt Quick painted item that lets you use a QPainter for your item to draw your components. The Qt Quick Canva that lets you draw HTML5 like close to HTML5. And else, of course, you can rely to existing components. So if you only display a rectangle on the application, I don't think that's useful to use that to draw that rectangle. Just put the rectangle element in Qt Quick and do that. Okay. And now a few elements that I can show. If I had a mouse, I would have better. Probably someone can continue the conversation while I'm connecting the mouse. Oh, nobody wants to continue the explanation. Okay, no problem. And sometimes after my mouse will clear. Okay, we do that. You see something? Yes. Okay. Let's close that. And let's try to run, for example, the simple one. Okay, so I will show you what it does right before. I think it crashed. That's always the first step of all the program is to crash. Yes, very good. But that's not what was planned. Because we need to add a few elements. And we'll do that really quick so you can look at it. So we have a simple program. On the QML side, really simple, and we have a direct element, which is our custom QQuick element. And inside some, another animation, so just something to animate a property in our component to make it move on itself. So we are on the C++ side now. We have our view item class. What we miss here is something probably nobody remember, so I will add it on my own, which is the set item contents. The element that you need as your component will just, actually the application crash, because you have to tell Qt, okay, my component needs to be drawn on screen. So that's the first thing, constructor, nothing very complex, some blah blah blah. And the update paint node, where we check if the size is 0, for example, of our element. If that's the case, we delete simply our node. And then, we retrieve the size of our element. We set the size of it. So here we have the node which is, well, it has a great name, which is n. Okay. We set its size from the size of the QQuick element. Maybe that's better. And what we do here, I will show you that that's like you have a spectrum, like maybe an infra player or something, and so you want all your bars to move. Maybe you have 1,000 bars on the screen, so maybe it needs to be accelerated. And so in this case, we will append a child node for each bar of your spectrum that you display for your MP3 player. So that's what we do here. We create simple rect nodes, and we add these rectangles, so these nodes, to the node of our item. Okay, no problem. Finally, we set blah 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 to make everything move. We set the position and the size of our rectangle, and we return the node that we have created. I think I miss one piece of code that I don't have the time to let you guess. Probably I wouldn't even be able to rewrite it on your own. Okay. Maybe So here we test if the node was created already or not, and if it wasn't, we create again a simple rect node just to show you that it's really convenient to do that manually. We set its color to white, and that's also what we should have is a white rectangle with inside some red rectangles, right? And what we did is we animated the count property, so the number of bars should change over time. Okay, it works. But it's not for now a spectrum, something you can put in your MP3 player, that's not, but it works. And that's really the point of it. And now probably I will show you the last thing, which is maybe, okay. Also I can't go through all the lines of the code because there is some. Here we directly use shaders, so fragment shader, to change the color of our spectrum bars to add some nice effects. It's always better with effects. And what you see here, for example, is the fragment shader used to change the color of each pixel of our case. And we so apply this formula, and as we are short on time, I will directly display the last one. So we use some magic as we counting. I don't have the time to explain to you. And blah 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 blah. Some code, mostly the same as before, with also I would say some magic added, just management of the node, etc. And we animated not the number but the size of now. Not the number, but the size. And the result is when it will be done. Okay. Something like that. Okay, probably not the best MP3 player or Spectrum or something, but still done with Qt Quick, with full Open GL acceleration and all that it implies. Thank you for. I think that was
I have a question.
Okay, fine.
Why you have to set the item as content flag? I mean, what are there any cases where I want to create an invitable QML application? If I have understood the meaning of that flag.
What you have often also is Quick components that have no appearance at all. Like for example, you want to create some Quick components that directly read some data from the database, something like that, and expose them on the Quick side. So you can create an item like that, and this item contains properties that actually have some values in your database. And that component has no appearance, but
is that component accelerated or not?
When there is no appearance, probably, yeah, the database is Open GL accelerated.
Other questions? How we can reproduce via GStreamer over a QML components using Open GL acceleration?
Which component?
Via GStreamer, I want to play over a QML components. Via API.
That's a good question. I really don't know. Probably I have some knowledge about some. Which component? Okay, now that is too complex for me. That's normal.
GStreamer.
Oh, GStreamer. Okay.
Hardware accelerated.
Yes.
Through API.
Yeah.
API.
Mm-hmm.
Through Open GL.
Okay, so let's say you have a stream, a video stream, and you want to include it inside a Quick application. Okay, that's a good question. I don't know if I don't have know the second piece of software inside, but in that case, I don't know so much is stream. You have to get somehow a pointer to frame buffer or an object that GStreamer outputs. And then from your side, you can create a QtQuick component and just create a textured rectangle and get back this image to show it inside the rectangle. So you just, for example, set the texture of your rectangle, taking the pointer to the data, image data that you have from GStreamer, from your application. That's something you can do. Something that can be done. I don't know, maybe there are some existing already things to integrate GStreamer to QtQuick, right?
They are useful. They are useful.
Yeah, okay. So maybe that's a solution, yes.
Thank you.
Okay, let's say thank you to Adrien.